Hello, and welcome to the fifth in my series of videos where I am documenting the restoration of my family's old Perpetuum Ebner Model 99V. In my last video, I removed the amp subassembly from the chassis, did a complete recapping and then check of all the resistors on both channels of the amps, then put the assembly back into the chassis and replaced the other capacitors that were not part of the subassembly. The recapping was actually easier than I expected. Even though the amp was quite compact, it was 2 amps in one. I just replaced the caps on one side, using the other side as a template, and when done, I just reversed the process. The next step in the process is to test the newly reassembled amplifier. I always follow the same standard procedure when powering up anything that I have worked on. I always do a current limited, slow power up to full working voltage. To accomplish this, I use 3 pieces of hardware: an isolation transformer, a current limiter, and a variable auto transformer. If you're going to get into restoring old radios or amplifiers or really any electronic gear, the first thing I suggest you buy is a high quality isolation transformer. On this schematic, you can see that there's no E or earth ground connection on the secondary side of the transformer. This is what you want. Be wary of something called a medical isolation transformer. These seem to pop up endlessly at garage sales. These are usually fully grounded, as a friend of mine discovered about the one he was using for a while. These are isolated for noise and not grounding. Not what you want. Remember, an isolation transformer is for safety, both your personal safety and the safety of any test gear you might be using. I'm not going to go into the gritty details of how an isolation transformer protects you, but I will put a link to a good video in the description. Now, the one I use is rather old, 1950s vintage, but that does not worry me in the least, as it was new old stock, it's test fine, and it's by a good brand name. And you might ask why I even bother with an isolation transformer with this amp, as the amp has a transformer, not only one but 2 fuses, shorting bars, and even the switch cuts off both sides of the line current. Well, there's always a chance that something is very wrong with the amp. A component might be shorted, the transformer might be miswired, or a wire might be touching the chassis. It could have a direct path to ground from any number of different causes. And if you happen to attach your oscilloscope probe, or your finger, in the right spot where there's a high ground potential, you will see a lot of smoke and sparks. Or if you were unlucky and touched it in the wrong spot, you might be having a very, very bad day. An isolation transformer will remove this path to ground. But it's not 100%. Never put both hands into any valve gear at any time. If you happen to get a shock going through one hand to the other hand, it's got to go through your heart first, and that sometimes has very fatal results. Now, the current limiter is what you want next. It's got to be one of the easiest pieces of kit to make. I built this one out of a bunch of spare stuff I had lying around the house, except for the 3-position switch. If you want to build one, just search for dim bulb current limiter, and you will find many examples on the net. It's probably the only piece of kit that you actually can't buy from China. You either have to build one yourself or pick one up at your next Radio Club swap meet. Please understand that this device only limits current. It does not stop it. It is there so you can quickly turn off the power when the bulb glows bright for too long. As the name suggests, it only limits damage. I have fried components when the bulb is only on for a few seconds. It all depends on the components and the bulb. In my setup, I use a 300-watt bulb. So if there's a short on, say, a 1/4 watt resistor, it would not take long for it to go up in smoke. So why use it then? Well, 90% of the time you will save your circuit, as the bulb will glow way too bright and you will spot it and turn the power off. Do not use a ground protection socket, a circuit breaker, or even a fuse in place of a dim bulb limiter. None of these will offer you the same protection. Finally, there's the auto transformer, or as it's more commonly known as, a variac. Mine is a little basic and quite frankly a little unsafe, but I'm very careful with it, and it is built to a very high quality. Again, don't try to cut corners and get, say, a dimmer switch. They just do not work. I hook my auto transformer at the end of the chain, so for me it's isolation transformer, dim bulb device, and then the auto transformer. Okay, well, let's get on with the video.
Go into test mode. Variac is off, bulb plugged in, power on. Set this to amps, 200 milliamps. Set this to volts, DC. AC to start. We'll crank her up to 50 volts. Let's see what we got. $50 volts. Okay, we're not drawing any power. We are getting AC in. Somewhere in here. Should be getting AC 7 volts. Wires are down. Yeah, we're drawing some power. Nope, that's still not correct. It's not pushing down hard enough. Now, turn her off for a sec. Switch back on. No shorts, that's good. $69 volts, okay. 70 volts, and we're reading about 50 volts out. Okay. Back on test. We're back up to 120. Still not drawing any current, which is good. A little dim bulb. 117 is what we should be testing out. This one. 115, good. So, test point 1. DC. $404 volts. And so let's try with some tubes, shall we? Turn that off. Turn master power off. Drain my caps. Just the big caps. Back over here. Tubes. My lovely tubes. 60 years old and used a lot. They look straight. Actually, there's no bad way to put them in. That's one. It's two. And we're all set. Off. Power. Give it a short test to see if it's not shorting. We'll get a glow. I don't have any load on it, so I have to be careful. Are we getting that magic glow? So we're not getting power into the system. Oh, that's because it's not connected here. Not connected to that switch. It's connected through there to the transformer, but the transformer comes out and goes to the switch. So we'll flow this off and take out the bulbs, tubes, the valves, I should say. Disconnect everything. Trying again. Swapped out the dim bulb for a bigger bulb. We're getting, let's see, 21 volts. That's not right. $150, 10, 12, 13, 14, 15, 16, 17. Close enough. No voltage. Tell me I blew a fuse. Must have drew too many amps. Let's try for 10 amps. Yeah, blue fuse. Yeah, well, it was drawing power anyway. Ah, getting glowing, yay! Glowing without smoke?
Say,
No, don't say that.
peanut
No.
butter sandwiches.
Without smoke? And how much is it drawing? I'm not drawing a lot of power. According to this, it's not even drawing an amp. But I am getting power in there. Not too good glow, not much heat. $117.5. Perfect. So, tonight I've got everything hooked up, so I can see all these wires. I've got some signal coming in from my computer actually, I'm not a signal generator, so I might blow up my computer tonight, or at least the soundboard on my computer if I'm not lucky, if I'm unlucky. I've got that going out from my computer, and I've got these coming in from my computer on these. These are going out to my dummy load. There's a box over here, I'll show you a picture of that. And for my dummy load, I go into the oscilloscope. So, let's turn her on. We should get some power in the tubes. We should get some nice glowing. Let's do the test down at the power level there. Voltage nothing. AC. Nothing. So when I get any power, but those are stupid breaker bars again.
Curses!
It's those damn breaker bars again. I bet you dollars to credits to Navy Beans. Let's try that again. There we go. Whoa, I heard a hum. Definitely heard a hum. Something's coming to life. Ooh, getting something. Whoa. Something dirty. Not get anything on the second channel though. Oh, get a nice sine wave out of channel 2, and look, a nice sine wave out of channel 1. Frequency channel 1. 15K. Oh, smooth as a dollar bill. Channel 3. There we go. Well, that's beautiful. No hum at all. Gotta love that. 60 years old and no hum. And a beautiful sine wave. Just a dirty pot. That's why I couldn't hear it, because my ears are gone. Ooh, 60 hertz. Oop, I'm getting oscillation. Oh yeah, hot plating or something. Ooh, cool. Hot plating. Fuzzy worm. Oh, got the fuzzy worm on one. Yeah, I think that tube is dead. Now that's quiet.
So no magic smoke, so I'm very happy about that. And I'm actually happy at the tone that came out of it. When you look at all the parts I replaced, 14 odd paper foil caps, 8 electrolytic capacitors, and 1 resistor, I didn't even make one mistake. I did hear some funny noises coming out of it, and a very odd trace on the oscilloscope, but that's for the next video.